Day, December 7th. Happy Pearl Harbor Day. Don't forget that, by the way. And we'll be talking about the upcoming snowstorm here for the Mid Atlantic region on Saturday, December 9th, and an event beyond that. So let's get right to it. Again, we'll be using a video here as opposed to the audio. It's just too much information to put out there. And at the end of the video here, you'll see the snow maps as well. So pay attention. A lot to talk about. All right. This is a temperature profile for you folks out there who don't understand the difference between snow, sleet, and freezing rain. So let's briefly go over this. Let's assume in each one of these diagrams that you are located right here. Okay? So if you're looking up at the atmosphere, when you have snow, let's say the cloud level is here, and this is usually your 850 millibar level. Okay? 850 millibars. Usually what happens in 95% of the cases, sometimes it's 750 millibars. This is 1 mile up, all right? 1 mile, 5,280 feet. So it's got to be cold in the wintertime from the cold season months, from the cloud base, 850, all the way down to the ground. As long as that happens, okay, all the precipitation falls as snow. Now, sometimes what happens is you can get a little bubble of warm layer in here. Let's say the system is coming up from Georgia and it's tracking up into, let's say, West Virginia. So that brings up southwest winds, and what happens is it creates a warm level here at the mid levels. So it's snow here, then it goes above 32 degrees, let's say about 3,000 feet or 2,000 feet, and as a result it changes over to rain. So now we have rain, okay? Just plain old rain, 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 rain. But then the last 2,000 feet, it's 25 or 26 degrees. So now you get chunks of sleet, and that's sleet. Now it's easy sometimes for the atmosphere to go from sleet back to snow because you only have this little bit of bump to get rid of. And then finally over here on the right hand side, this is freezing rain. And here what happens is you have snow up here at the top of the just coming out of the cloud, but a much bigger area of warm temperatures. Let's say from 5,000 feet down to 1,000 feet. So 4,000 feet of warm temperatures. The temperature here could be, let's say, 40 degrees. Really, it could be. And then the last temperature, you're on 30 degrees, 29 degrees, last 1,000 feet. So the rain freezes as freezing rain in contact. It doesn't become sleet, but it becomes ice cold and it freezes on contact, and that's freezing rain or freezing drizzle. So that's basically your temperature profile problem during the winter months. Now, earlier today and yesterday, it looked like we were going to have a fairly big area of warm layer in the mid levels on Friday and Friday morning, Friday afternoon. So when the precipitation would start, it would begin as rain and continue raining to Friday night, ending and turning over to snow. But it wouldn't last that long through Saturday morning, and it wouldn't have a chance to accumulate too much except for a little bit on the colder surfaces like grassy lawns, car tops, what have you. That's what the old data was showing. All right, things began to change this morning. And we'll do this. Oops, jumped ahead. This was the NAM from this morning, the 3 kilometer high resolution NAM. And you can see that in Richmond, for example, 5 inches of snow, and then Salisbury, 9 inches of snow, 3 inches up in DC, close to Baltimore and to Philly. Nothing in Charlottesville or Roanoke, Lynchburg, and then a band of snow here in Greensboro as well. And you can see the snow continuing up to New York City. Not a huge snowfall, but obviously over the Delmarva and southern New Jersey, you can see it's got pretty significant snow, well over 6 inches on the NAM, which, by the way, as we know, still has a wet bias. But then the GFS model came out, and let's compare the difference here. And I posted this on the Facebook page and on the Twitter. Now, the image on the left, this is from Wednesday, yesterday, valid through 7 p.m. Saturday night. Now, the green and the blue line, you see this right here, the green and the blue line, that is that's a half inch of liquid. So that's barely through Norfolk and then down here, Elizabeth City. Richmond is in a quarter of an inch, and then look how dry it is up in D.C. and New York, and that's what everybody's saying this morning that's going out to sea. Don't worry about it. Roanoke is dry, Charlottesville, Lynchburg, everybody's dry. Now look at the difference here from this morning. This is Thursday, also valid the same time frame. This is that half-inch line. It's now well north of Richmond, up towards St. Mary's, Dover, close to Philly and New York City. And then out there by western North Carolina. There's Raleigh in this area. And then, of course, the 1 inch line, which is the light blue, that's in here. That's well to the west of Norfolk, between Norfolk and Richmond. So this is a whole massive shift of precipitation to the west. That's what this is showing. Now, here's the 12Z GFS. This is the GFS ensemble. and came out, you can see that it actually has the actual precipitation. Again, this purple stuff is 6 inches. So a couple of 6, a few 7 inches. This is down by South Hill and South Boston and Greensboro. Richmond is around 5 or 6 inches. Dover, Salisbury, the same sort of thing. Cape May, New Jersey. And again, the 2 inch line, that is this on this model. That is where the blue and the gray just meet. That's 2 inch line here. So this is Smith Mountain Lakes. Roanoke is on the 1 inch line. Charlottesville, the 1 inch line. DC is on the 2 inch line. Baltimore, 2 inch line. Philly's about 3 inches, and so on and so forth. That was the GFS ensemble this morning. And you compare that to this is just an extension. You can see continuing up into the New England area, so you can see a little better here. But again, I posted the cities so you can see where the proximity was on the GFS ensemble, which is pretty impressive. Then the European started coming out. Now this is the precipitation type from the European. The image on the left is valid 7 a.m. Saturday morning. So we can see that here. 7. Let me get a marker. 7 a.m. Saturday morning. And you can see snow, Greensboro all the way down here. This is Raleigh, so it's raining in Raleigh. And then a mix over Emporia, and then to Williamsburg it's mixing. But Richmond is there, snow. They got light snow in Charlottesville, close to Roanoke, Lynchburg, that sort of thing, D.C. And then moderate snow also up into southern Delaware and Maryland Eastern Shore. Now this is 1 o'clock on Saturday, and it's still freaking snowing. In fact, it's snowing pretty darn good over a lot of places. And that's with the northeast winds bringing down the cold air. And now, Raleigh's gone over to some sort of mix at that point. Greensboro is still snowing. Now, look what happens on the back side of it. When the precipitation gets really light, it goes back to rain. See, it was snow over here. When the precipitation goes back to over the precipitation is light, the warmer air comes in at the low levels and it goes over to rain. Rain. See that? So there you go. Notice on Hampton Roads, it's still almost completely all rain. Now that's an important feature. Again, the temperatures are going to be important to this whole situation when the precipitation comes down heavy. If for any reason, folks, these models are busted and they don't get and the precipitation doesn't come down that heavy, snow amounts are going to be way off. Just to let you know. Okay, this is the GFS ensemble on the left, which I posted just before. You can see that. And then this is the European. And I'm using the European Kushera. I'm not using the regular European you get from Weather Bell or from Weather US because they're just overhyped and they're overdone. And they count all mixed precipitation as snow, which is bullshit. So, Richmond metro area, 4 or 5 inches of snow. There's a band of 3 to 4 to 8 down in here. Greensboro, South Hill, that area. And Roanoke is just on the 2 inch line. Charlottesville's 3 inches, DC's 3 inches, Philly's 3 inches, and so on and so forth. And again, Salisbury, Maryland, pretty significant snow there as well. All very reasonable and in very close agreement. The agreement here between the GFS on the left hand side and the European is quite strong. So that's an encouraging sign. And this is the European continuing. Again, the Kushera projections up into Boston. A nice solid 3 to 6, 4 to 8 inch snow in eastern New England, 3 to 6 in New York and Philly and New Jersey. Maybe a few 8 inches on the Jersey coast. Now, this is the European weather map from EuroWeather, and they use the Kushera algorithm, but also things a little differently. And this is usually the conservative projection. So you can use this one as your base low end. So use this one as your base low end. Okay? So we can do that. And again, notice there are some 4-inch snows, which is very decent for early December. In the Richmond metro area, down southward towards South Hill and South Boston towards Greensboro. And then also some 6 inches in Salisbury, Maryland, and 4 inches up towards in southern New Jersey. Close to Philly. Philly's about 3, New York City, and then into Connecticut. So again, excellent representation here of the low end of what it could be. Now let's look at the ensembles. Now the image on the left, this is the one from early Thursday morning. And you can see here that the blue is the deterministic or operational run. So it had almost no snow from this morning, but the ensemble mean by Saturday night had about 2-inch snows in Petersburg. This is the new one in here. Look at the monster change. Now the green, the purple, the blue here that's the deterministic, again, the operational run. So you can see right in here when the precipitation has ended on Sunday morning, 5.5, 6 inches, and the ensemble mean is over 6 inches. Big snow for Petersburg and southern Chesterfield County. And again, these are the different spreads. These are the different 51 models, 51 members of the ensemble, of the European ensemble. Look how many of them are 6 inches or more. Remember, the 6-inch line is the purple line, okay? So look how many are 6 inches. This one here, and this one, 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 and blah blah blah. A lot of them over 6 inches in southern Chesterfield County, Petersburg. This is Farmville. Look at the change of Farmville. Again, the ensemble mean and the deterministic very close, about 4 inches in Farmville. Danville, about 4 or 5 inches. This is Salisbury, Maryland. Whoa! 8 inches on the ensemble mean and the deterministic run. And look at all the purple in this one here. Remember, the purple color, folks, again, here's the base 6 inch line right there. You see that? Right in here. And the purple stuff, this is like 7, 8 inches in here. So you have an awful lot of 7, 8 inches throughout all these things here. So the Salisbury is the place to be in southern New Jersey for this event, according to the European. Here's Franklin. The blue is the operational run, about a ½ inch to an inch, but the ensemble mean about an inch. Williamsburg also does really well. Now, Williamsburg is really close to that line. This is a tricky forecast. The operational run has 5 to 6 inches in Williamsburg, the ensemble mean about 5 inches. That's possible to the especially the north side of Williamsburg. But as soon as you go east of Williamsburg, you head down towards Newport News, the precipitation amounts really, really drop off. And this one here is Danville, and you can see also decent snow in this area as well. All right, now let's take a look at the GFS ensemble. The 18Z came out, and you can see some impressive stuff here. This is Friday afternoon, and notice that most of the precipitation is not beginning here. This is all light stuff. This is Friday at 1 p.m. Okay, good. Now this is your 32-degree line, the blue line, and this is your rain-snow line 1 mile above the ground. So very light rain in here, 35, 34 degrees, not, again, 1 o'clock in the afternoon. This was much delayed. By this time, on the data yesterday, the heavy rain was already supposed to be in most of Virginia. So this is the difference. This delay means that the cold air gets to come in further from West Virginia, Pennsylvania, into Virginia, and the precipitation comes in heavier. So the 0850 isotherm, the purple line, gets into Norfolk, okay, but south of Richmond, and the cold temperatures come pouring southward, headed towards Lynchburg and Charlottesville and Richmond and D.C. by 1 o'clock on Saturday morning. Now, by 7 a.m. Saturday, it's snowing like hell in Richmond, according to this. It's raining in Norfolk. You can see everything south of the purple line on the left-hand side. This is 7 a.m. Saturday morning. 7 a.m. Saturday, see the purple? This is all rain. All in here, this is all rain. All right, but north of the purple line, close to the blue line, it's all snow. So Richmond is all snow, Danville's all snow, South Hill, Boston, Greensboro snow, Lynchburg is snow, Farmville snow, Charlottesville, maybe Roanoke now, D.C. is getting light to moderate snow, Salisbury, Maryland getting hammered. You can see that right there, and then it goes over. And then by 1 o'clock on Saturday evening, it's still snowing back towards Greensboro, Lynchburg. Moderate snow is just left Richmond or about to leave it. And here's the rain snow line here. So it's still coming down. As long as that precipitation is coming down heavy, you got all snow at 32 or 33 degrees. This is the 18Z NAM. Good googly moogly. Is that a 10-inch line I see in Richmond? It certainly is. 11 inches in Hanover, 8 inches in Petersburg. Is that right? Yeah, it's really gonna. This is a big push. But usually 18Z is too wet. So, you can take that 2/3 of it, the people take a 3/4 of it, 2/3 of it. That would be much more reasonable, but still that's significant snow. And look how sharp the line is here, folks. Look at this. There's Williamsburg right here. Okay, 7 inches on the north side, nothing in Newport News. This is Gloucester, Matthews, same sort of thing. Tappahannock gets crushed. On the bay, nothing. Ocean City gets very little. Salisbury, 9 inches. Very, very distinct line here. So, Greensboro gets a little less snow on this map than the other models, but still a decent snow for them. Here's the local TV here in Richmond. The only person that seems to have a clue is Jim Duncan, of all people, and he's got the potential for several inches of wet snow. I'm not sure what Bernier's looking at over here. I don't know what that's about. That's just whatever. And again, same sort of thing here. Very safe. This one here is a replica, and this one here, they're both replicas of NWS forecasts. A word for word, no actual forecasting being done there. Now, you look at the 18Z GFS, it actually increased it. It almost matches the NAM. I'm like, really? I thought it'd be less, but it not. As you can see, again, this dark, this pink stuff, this is like 9, 10 inches of snow in here, folks. See that? There's Richmond. And then it goes up to Tappahannock, into Salisbury, Maryland, up towards Dover, central, southern New Jersey. Greensboro gets crushed on this thing. In the mountains of North Carolina. Oh, and here's Smith Mountain Lakes. So Roanoke is right about here. Roanoke's about 4 inches now, according to this. 3 or 4 inches. Charlottesville is 3 or 4 inches. DC's 3 or 4 inches of snow. So this is a big change. This is pushing this 2 inch line up to the north into the Shenandoah Valley. So that's pretty impressive snow, folks. All right, my snow map. This is most likely. This is I'm basing this on the fact that the grounds are really warm and the roads are really warm, and I don't know if there's going to be a lot of stickage on there. So this is my most likely first guess snow map. This is first guess, not the final form snow map. First guess, 2 to 4 inches, as you can see in the Richmond area, across the northern neck, Salisbury into Jersey. 1 to 2 inches in a large swath every place else, and then 2 to 4 in the mountains of North Carolina. Now, that's first guess. This is subject to significant increase. I want to see if this trend continues. I don't want to see a flashback here on the 0Z model runs. Now, this is high end. This is my top end. If the model trend continues and the data continues, we could see this. So that's also impressive. This is a big range. The borderline temperatures here are a real problem. I want to make sure that trend continues. And if it does, we'll start to move in first call and last call maps will begin to increase the snow amounts. This is meteorologist DT with the video podcast. I'll talk to you on the Twitter page and on the Facebook page.